This video is going to have a look at alcohols. You'll learn how to produce alcohol and the effects of it. If you think back to alkanes, such as methane here, it's a hydrocarbon made up of only hydrogen and carbon. The difference between a hydrocarbon like an alkane like methane and an alcohol is one particular group. An alcohol contains an OH group. So if I wanted to change methane into an alcohol, all I would do is remove one of the hydrogens and put an OH group. So that's one oxygen and one hydrogen. The naming is similar all the way throughout all of the alkanes. All you do is you take the last bit off and put OL onto the end. So it becomes methanol. In terms of the structural formula, you make sure the OH goes separately to show you that it is an alcohol. So this changes to CH3OH. So I've got 4 hydrogens in total, 1 oxygen, 1 carbon. This is exactly the same for all of the other alkanes when you convert them into alcohols. The nomenclature is the same and the structure is the same. All you are doing is adding another CH2 every time, and I'll show you what I mean by that now. So you start off with methanol, CH3OH, add a CH2 in, and you get ethanol, which looks like that. So one extra CH2 group in, which makes it C2H5OH. And again, the original name for that when it was an alkane was ethane. So ethane, ethanol. Propane becomes propanol with the formula C3H7OH. And butane becomes butanol. This will continue for pentane to pentanol and so on all the way through to the end. If you wanted to work out the general formula for this, use this formula here. So if you had 10 carbons, what you would do is double it. So that's 20 hydrogens plus 1. So I'd have 21. So it would be C10H21OH and so on. So this formula here, CnH2n plus 1 OH, is something you can use in the exam to work it out regardless of how many hydrogens, how many carbons they give you. Right, that is how you know what an alcohol is. Now it's how you make it. And that's a process you should have come across in biology and you should have come across just in your normal life called fermentation. I'm going to show you how that works now. So you start off with sugar, which is otherwise known as glucose. This sugar, this glucose, normally comes from carbohydrate plants such as sugarcane and sugar beet, and then what you do is you turn it into a solution and you add yeast. Now yeast is an enzyme that is used to break up the glucose into your alcohol and water. Glucose normally comes from plants such as sugarcane, sugar beet, and when you add it to yeast when it's in a solution, it will break that up into your alcohol and carbon dioxide. If you want to have a go at balancing this now, you've got 5 seconds, so pause. That's what you should have got. Okay, so glucose is broken down by yeast into ethanol and carbon dioxide. So let me just run through that with you one more time then, the process of producing alcohol from sugar. So number 1, mix yeast with a solution of a carbohydrate or sugar. Now what I mean by solution is it's that sugar dissolved into water. Number 2, seal a container to prevent oxygen from entering. If oxygen does get in excess, then the ethanol will turn into ethanoic acid, which is vinegar, which obviously you don't want when you're making alcohol. Step 3, warm it to between 30 and 40 degrees. It makes the catalyst work at the fastest possible rate. However, don't go too high. If you go above about 37, then the catalyst will start to break down and the reaction won't work. When it's been converted to about 10-20% alcohol in the solution, it will stop. The reaction will not continue. The reason for this is the yeast will get killed off by the alcohol. Therefore you use a process called distillation to increase the strength. The yeast will fall to the bottom and then you'll be left with your alcohol on top in a solution which you'll be able to remove. Most of the beer and wine that people drink is less than 20% alcohol. The reason for that is because fermentation doesn't produce it any higher. So the process that we use if you want to make a spirit is fractional distillation. You should remember that back from year 10. So what happens here is you take your dilute ethanol, which you've produced from fermentation, and you heat it up. At certain temperatures, ethanol will start to evaporate. The boiling point of ethanol is 87 degrees, which is slightly lower than water, so the ethanol will come off first. So the ethanol rises up the fractionating column here, and then will start to come down this tube. As it hits the Liebig column, water is coming in here and out there, and it cools down the ethanol, so it will start to turn back into a liquid to condense. It will then come down into here and will be collected. Now, as long as you're careful, the water will stay in here if you keep it below 100 degrees, and you'll be left with pure concentrated ethanol here. There's one major benefit and one major drawback to using fermentation then. The major benefit is that it's renewable. So that means that the sugarcane and sugar beet that you use to produce the ethanol won't run out as long as you keep planting more. However, the negative side of fermentation is that the quality you make is poor. Therefore, it's expensive to concentrate using fractional distillation and purify. That uses up your fossil fuels, etc., etc.